Welcome to a new episode of the podcast. Box Agent is made by AI for business executives that work with AI. Today, we're embarking on a pretty crucial deep dive into a challenge that's perplexing many in the world of artificial intelligence, large language model, or LLM hallucinations. Imagine this scenario. Your AI-powered financial analyst confidently reports a completely new market trend, maybe citing specific, plausible-sounding data points, only for you to discover later that those trends, and yeah, the data too, are entirely fabricated. Or maybe a medical AI offers a diagnosis that, it sounds coherent, but it's actually medically impossible given the patient's records. That is an LLM hallucination, and honestly, for any executive working with AI today, understanding it is absolutely critical. Our guide for this deep dive is a really comprehensive research report meticulously compiled by Vox Agent. And this report, it doesn't just scratch the surface, it meticulously analyzes the fundamental causes of these AI missteps, their far-reaching impacts across various industries, and crucially, the practical, actionable solutions available. So our mission today is pretty clear.
We're going to break down why these incredibly powerful models, despite all their brilliance, sometimes they make things up. We'll explore what that means directly for your business, and most importantly, what tangible steps you can actually take to mitigate these risks and build more reliable AI systems. Okay, so let's unpack this concept of hallucination in LLMs. It's not like the AI is having a fever dream or, seeing things that aren't there like a person would. What the Vox Agent report makes really clear is that it's when these models generate outputs that are factually incorrect, maybe nonsensical or downright misleading, but and this is the kicker, they often sound incredibly convincing, plausible even. It's more than just a simple error, you see. It's like a confident fabrication, a plausible untruth. We're talking about fabricated facts, statements that seem coherent at first glance but then kind of unravel under scrutiny, or even biased outputs that stem from inherent flaws in their training data. It's the AI essentially creating its own reality and then presenting it as fact.
Yeah, what's truly fascinating here, and maybe a bit unsettling, is that these aren't just, accidental typos or minor glitches you can easily patch. The research explains that they actually stem from deeper systemic issues within the model's fundamental design and its training architecture. When an LLM hallucinates, it's not just making a mistake, it's fundamentally undermining the trust we need to place in that AI system. Think about it. If an AI can't reliably tell fact from fiction, how can we confidently integrate it into critical business processes? The real-world consequences can range from, significant financial losses to severe operational disruptions, and as we've seen, even reputational damage that can take years to rebuild.
And that's precisely why you as a business executive really need to pay close attention. The stakes are incredibly high here. We're talking about direct financial risks, like an AI incorrectly advising on an investment strategy, or the potential for severe consequences in critical applications, think aiding in medical diagnoses or even legal research. The report doesn't pull any punches. It really emphasizes these economic and reputational costs. It's not just some technical detail for your engineering team. Addressing hallucinations is a core business imperative that can directly impact your bottom line and your brand standing. It's truly perplexing, though. We expect such brilliance from these models, yet the report highlights they often just make things up. What does the Vox Agent research suggest is maybe the most surprising or perhaps the most fundamental reason behind this?
Yeah, that's a question that really goes to the heart of how these systems operate. The Vox Agent report breaks down the multifaceted root causes pretty effectively. One of the most significant factors is definitely limitations in the training data. LLMs are trained on truly colossal data sets, right? Drawn from the internet, books, all sorts of sources. But these data sets are far from perfect. They can contain inaccuracies, incomplete information, and even reflect societal biases, which is a huge issue. So if, for instance, a data set has an overrepresentation of certain viewpoints or maybe just outdated facts, the model will learn these patterns, and it reproduces those flaws. It's sort of like teaching a student with an incomplete or biased textbook. They'll confidently fill in the gaps with what they think makes sense based on that incomplete picture.
Right, makes sense. Flawed input leads to flawed output.
Exactly. Then you've got the architectural flaws and optimization trade-offs that are kind of inherent in LLM design. The core of these models is their probabilistic nature. They're designed primarily to predict the next most plausible word in a sequence, not necessarily the next most truthful fact. That's a key distinction. So model optimization often prioritizes generating fluent and coherent text, making it sound natural and convincing, even if the underlying facts are shaky or, outright false. And during inference, that's when the model is actually generating a response. Computational constraints can also limit its ability to thoroughly cross-reference or verify information from its vast internal knowledge base. It often defaults to what sounds good, not necessarily what's factually verifiable.
So if I'm understanding correctly, the core issue is that these models are just incredible at predicting the next most plausible word, not necessarily the next most truthful fact. That's a fundamental distinction for us as decision makers, isn't it?
Precisely. And that leads directly to the next point: the lack of grounding and real-world knowledge. LLMs operate primarily on statistical patterns they find in text. They don't possess a true common-sense understanding of the real world or factual evidence in the way a human does. They might confidently describe, say, a fictional historical event as real if the narrative is internally consistent and grammatically sound. Why? Because they're excellent pattern matchers and effectively storytellers, not necessarily truth tellers. They don't know things consciously. They predict based on learned patterns.
So they can build a very convincing house of cards, essentially.
That's a good way to put it. Another critical aspect the report highlights is inadequate evaluation and feedback mechanisms. Traditionally, the metrics used to evaluate LLMs have often focused heavily on things like fluency, coherence, grammar. Factual accuracy, while obviously important, has often been a secondary concern or just harder to quantitatively measure at scale. So, without robust feedback loops specifically designed to penalize factual incorrectness, models have less incentive, if you will, to learn from their mistakes or to distinguish hard facts from plausible fictions over time.
Okay, so the way we measure success has sometimes missed the mark on truthfulness.
To an extent, yes. And finally, a surprisingly significant factor is the role of prompt engineering and user interaction. How we formulate our questions, the prompts we give these models, profoundly impacts their outputs. An ambiguous, vague, or maybe poorly formulated prompt can inadvertently steer the LLM towards plausible but factually incorrect outputs. Plus, if users aren't diligent in identifying and correcting inaccuracies when they see them, their interactions can sometimes inadvertently reinforce erroneous information. That creates a negative feedback loop that actually perpetuates hallucinations.
Right, so how we talk to the AI matters a lot. We might even accidentally teach it the wrong things if we're not careful. It's clear this is a multi-layered problem with many contributing factors, from the data they learn from right down to their very design. But the real challenge for businesses, it seems, is knowing when an LLM is actually hallucinating. Is there a clear red flag, a single, reliable way to detect these errors?
Well, that's where the report highlights one of the biggest practical challenges: detection and measurement. While qualitatively, a human can often spot a completely nonsensical or clearly incorrect output, quantitative measurement, especially for subtle inaccuracies hidden in plausible text, is incredibly difficult. The report aptly calls this the mirage of hallucination detection. Many current metrics are, frankly, superficial. They might assess how well the AI constructs a sentence, but completely miss subtle factual inaccuracies or biases embedded in what appears to be a perfectly plausible response.
A mirage. So it looks like we can detect it, but maybe we can't. Not reliably, anyway.
It's often harder than it looks. There's an emerging approach using LLM-based detection systems, basically, using one LLM to check the work of another. It sounds clever, and it can be useful, but it comes with its own set of risks. The report calls it the double hallucination problem. This is where the detection LLM itself might make a mistake, might misinterpret something, leading to false positives or false negatives. You're relying on another potentially flawed system. Plus, deploying two LLMs concurrently, especially for real-time verification, can be computationally expensive, which limits scalability for many business applications.
So using AI to catch AI isn't a perfect fix either.
Not yet, anyway. And we absolutely cannot overlook contextual dependency. This is huge. The severity and the actual impact of a hallucination vary wildly depending on the context. A false statement in, say, a casual chatbot interaction about movie trivia is very different from an incorrect legal precedent started by an AI in a contract review system, or, heaven forbid, an inaccurate medical diagnosis suggestion. This really necessitates highly domain-specific evaluation metrics that accurately account for the specific application and its associated risks. What's maybe acceptable, or at least low risk, in one use case could be utterly catastrophic in another.
That's a really powerful point. So for you, the business leader listening, accurately detecting these subtle errors isn't just some technical curiosity. It's absolutely crucial for risk management, especially in those high-stakes fields like healthcare, finance, legal services, where the impact of even minor inaccuracies can be catastrophic. Having robust, context-aware detection methods isn't just a nice-to-have, it's really a non-negotiable necessity. It comes down to trust, doesn't it?
How do you quantify that trust, and how do you ensure the AI systems you deploy aren't silently eroding it? Okay, so we've dissected the causes, we've wrestled with the challenges of detection. Now for the really crucial part. What are the concrete, actionable strategies proposed in the Vox Agent report to actually combat these hallucinations? What can we as leaders do about it?
Right, the solutions. The report details a multi-pronged mitigation strategy, and it emphasizes that no single solution is a silver bullet. It's a combined approach. Firstly, there's enhanced data curation and pre-processing. This means moving way beyond simply gathering vast amounts of data. It involves rigorously cleaning, verifying, and augmenting training data sets to minimize explicit biases and factual errors before the model even sees the data. Think of it like building a much stronger, meticulously vetted foundation for the AI to learn from. You're actively reducing the chances of it learning bad habits right from the source material.
Better ingredients, better AI, basically.
Essentially, yes. Secondly, we're seeing significant advancements in architectural refinements and model design. This includes innovations like incorporating factual verification mechanisms directly into the LLM's architecture. It can also mean integrating external verified knowledge bases you might have heard of, retrieval augmented generation, or RB systems. These allow the model to consult authoritative, up-to-date sources outside its core training data for specific, factual queries. Now, of course, RV systems aren't perfect either. If the retrieved information is flawed, you still have a problem, so source quality remains paramount. We also see improvements in things like attention mechanisms, which help the model focus on the most relevant parts of the input context more accurately.
Okay, so building smarter models and giving them better external references.
Exactly. Then there are advanced training methodologies. Techniques like reinforcement learning from human feedback, or RLHF, are becoming incredibly important. Here, models essentially learn from human preferences. Humans rate different outputs, teaching the AI to distinguish factual information from fabricated content, and the model gets explicitly penalized for producing hallucinatory outputs during training. It's really about embedding human judgment directly into the AI's learning process, teaching it to discern truth from fabrication, almost like a wise editor would, helping the model align its outputs more closely with our understanding of reality.
So essentially, it's about embedding human judgment directly into the AI's learning process, teaching it to discern truth from fabrication like a wise editor. That sounds like a powerful way to maybe course-correct the AI's storytelling tendencies.
Absolutely. And building directly on that, the report crucially emphasizes incorporating feedback loops and human-in-the-loop systems. This isn't just a technical fix, it's often an operational necessity. It means having human experts actively review and correct model outputs, especially in real time or near real time. In those high-stakes domains we talked about, healthcare, finance, legal human oversight isn't just beneficial, it's absolutely critical for accuracy, for safety, and for accountability. These systems provide a continuous learning mechanism for the AI, guided by expert human intuition and correction.
So humans stay involved, especially where it counts most.
Definitely. And finally, there's a simpler but often overlooked technique that can yield significant results: prompt engineering. Just carefully crafting the prompts, the instructions you give the AI, can dramatically reduce the likelihood of erroneous outputs. By designing prompts that explicitly require factual verification, or maybe ask for evidence-based responses, or guide the LLM towards specific, verifiable data points, you effectively instruct the AI to be more diligent in its factual recall. You reduce its propensity to just invent information. It's about giving the AI a better roadmap to the right kind of answer.
This is where it really gets practical for your bottom line, doesn't it? How do these hallucinations actually manifest in different industries, and what are the truly actionable recommendations that you, as an executive, can take away from this? The report offers some compelling case studies.
Indeed, the report really brings these concepts to life with specific examples. In healthcare, for instance, they observed AI systems hallucinating improbable diagnoses. Imagine a system suggesting a patient has, I don't know, a rare tropical disease while they're sitting in a clinic in, say, Chicago in January. A clear red flag for a human, but a plausible sounding fabrication from the AI. The mitigation here wasn't just about getting more data. It was about integrating real-time feedback loops directly from doctors. Physicians would review the AI suggestions, flag inconsistencies, and that human expertise immediately informed model retraining and refinement. This isn't just a technical fix, it's a critical safety net and a continuous learning mechanism.
Real-time doctor feedback. Got it. What about finance?
In financial services, the report highlights cases where AI confidently made up non-existent market trends. You can imagine the consequences. This could lead to flawed risk assessments and potentially very costly investment decisions based on phantom data. The solution there involved significant data enrichment with real-time market information, coupled with algorithmic adjustments specifically designed to better detect anomalies and flag any invented data points. It required grounding the AI's predictive capabilities in the absolute freshest, most verified financial data available.
Grounding in real-time data. Makes sense. Manufacturing.
For manufacturing, predictive maintenance systems, the ones designed to foresee equipment failures, sometimes made errors, often based on incomplete or subtly flawed input data, maybe old sensor readings. They addressed this by integrating real-time sensor data directly into the system. This grounded the AI's predictions in the actual current operational status of the machinery, rather than relying solely on potentially outdated historical patterns. That shift from purely historical to real-time verified data was crucial.
And customer service. We
Right.
see a lot of AI there.
Yes, and in customer service, where chatbots are increasingly common, inaccurate information was, unsurprisingly, damaging customer trust and leading to frustration. This was tackled with a more multifaceted approach. Improving the data curation for the chatbot's knowledge base, much more rigorous testing of its responses against a verified fact set. Implementing continuous monitoring of interactions to spot inaccuracies quickly, and actively soliciting customer feedback to identify and correct any hallucinatory responses. You see, each industry requires a somewhat tailored approach, but those underlying principles, data quality, human oversight, continuous learning, they remain pretty consistent.
So given these diverse challenges and solutions across different sectors, what does this all mean for the C-suite? The Vox Agent Report doesn't just lay out the problems, it offers clear, actionable, strategic recommendations. These are designed specifically for executives to navigate these complexities. What are the key takeaways for leadership?
Absolutely. These recommendations are designed to be practical, strategic directives. First, and maybe most importantly, invest in data quality and infrastructure. This means prioritizing rigorous data processes, vetting, cleaning, verifying information, and building the necessary infrastructure for robust feedback and verification systems. It's really about treating your data as a core strategic asset, ensuring its integrity from the ground up.
Data is foundational. Okay, what's next?
Second, foster a culture of AI literacy and critical awareness throughout your entire organization. It's simply not enough to deploy AI tools. Your employees, from frontline staff right up to senior leadership, need to be trained. Trained to critically evaluate AI outputs, understand its inherent limitations, and know when to question its conclusions. This builds a kind of human firewall against hallucinations.
Empowering the people using the AI. Got it.
Third, develop robust AI governance frameworks. You need clear policies. Policies for AI usage, including how you evaluate model outputs, how you implement continuous feedback loops, and how you strategically address any data integrity issues that arise. This isn't just about compliance checkboxes, it's about building sustainable trust and ensuring responsible AI deployment across your enterprise.
Governance is key. What else?
Fourth, embrace hybrid AI models. The report strongly suggests considering combining advanced AI systems like LLMs with maybe more traditional models, or even simpler rule-based systems for cross-verification. This reduces your reliance on a single, potentially fallible AI system for critical decisions. It provides redundancy and a stronger foundation for accuracy. It's about building robustness through diversity in your approach.
Don't put all your eggs in one AI basket.
Precisely. And finally, number 5. Prioritize continuous monitoring and improvement. Implement systems for ongoing evaluation of model performance, not just at the launch, but constantly throughout its lifecycle. This allows for timely adjustments, retraining, and enhancements based on real-world performance and feedback, ensuring your AI systems evolve and hopefully improve their factual accuracy over time.
It sounds like a continuous journey, not a one-time fix. This clearly isn't just a technical challenge for your engineering teams. It really touches on fundamental issues of trust, ethical deployment, and frankly, the very future trajectory of AI in our businesses and society. What are the broader implications here that executives should be considering for their long-term strategy?
Oh, the broader context is incredibly important and complex. From an ethical considerations standpoint, the black box nature of many LLMs can make it really challenging. Challenging to pinpoint the exact source of an error, or critically, to assign accountability when errors occur, especially when they lead to adverse outcomes for individuals or the business. This really highlights the growing need for explainable AI or XAI techniques that aim to bring greater transparency to these systems, allowing us to understand how they arrive at their conclusions, not just what their conclusions are. That's crucial for trust and and accountability.
Transparency and accountability. Big themes. What about rules and regulations?
Right, then there's the rapidly evolving regulatory landscape and compliance. The global regulatory environment for AI is, well, fragmented and still very much in flux. We see significant initiatives like the EU AI Act emerging, but different regions are taking different approaches. This creates complex legal questions around liability for erroneous outputs generated by AI. Who is responsible when things go wrong? Businesses really need to be proactive here, staying informed, complying with evolving regulations, and where possible, engaging with policymakers to help shape these frameworks in a way that encourages innovation while ensuring safety and building public trust.
Proactive compliance and engagement.
Oh.
Not looking for.
Looking ahead, the report points to some exciting future trends in research that promise to further mitigate these challenges. We're seeing ongoing work in advanced data management, think automated cleaning techniques, using synthetic data to fill knowledge gaps or reduce biases without relying solely on real-world, potentially flawed data. There are also evolving model architectures being developed, specifically designed to prioritize factual accuracy and explicitly integrate verified knowledge sources more deeply. Plus, continued improvements in explainability techniques and the development of more scalable real-time feedback mechanisms. All these efforts are fundamentally geared towards building more inherently trustworthy and robust AI systems for the future.
It sounds like the field is moving fast to address this. Which brings us to a final thought. This raises an important question, I think, for all of us as we navigate this AI frontier. Given these inherent complexities and the continuous evolution of these models, how can we move beyond simply minimizing hallucinations to actually engineering inherently trustworthy and transparent AI systems that build genuine confidence and truly augment human decision-making, rather than just creating new kinds of blind spots for us to stumble into?
That really is the defining challenge and perhaps the biggest opportunity for this whole AI era.
Thank you for joining the podcast, and see you soon.